I want to get started reviewing for test 3. This is Math 110, Intermediate Algebra. Let's take a look. Use the square root property to solve this equation. Square root property says if you got something squared and you want to solve that equation, you could just square root both sides. But it's a little bit more complicated because when we just square root both sides, it cancels out the square and we get z plus 5. But the other side becomes plus or minus the square root of the result. So now if we wanted to solve it, we need to subtract 5, and so we end up with two answers. Z equals 5, negative 5, plus or minus the square root of 5. Solving by completing the square, I really like, because it says this is something I can't factor. So let's say we can't factor it. Now this is going to be, it looks like 5 and 2, so I probably would just factor it. But let's imagine we can't factor it, and we say x squared plus 10x plus something would be a perfect square. And we say 7 isn't a perfect square. 7 is not a square at all. So what we can do is we subtract 7 from both sides. So now it's a negative 7 over here. And we've opened up this perfect blank space. And I know that since 10 is in the middle, half of 10 is 5, and 5 squared is 25. So I know that if I put a 25 there, it would make this problem nice and pretty, because I'd be able to factor it to just x plus 5 squared. The problem is I can't just put a 25 there because I want to, unless I also put a 25 on the other side. And then I can do that because that's what algebra says. From here, we can now square root both sides. And if I do that, I get x plus 5 equals plus or minus the square root of 18. So as we look at this, we go, oh, now I need to subtract 5 from both sides, and I get negative 5. Plus or minus the square root of 18. If you want, you could try to simplify that a little bit further. If you need to simplify your answer, just remember to watch out for things like that square root of 18 is really the square root of 9 times the square root of 2, or 3 square root 2. So depending on the way it asks for your answer when you're doing a problem on a quiz or a test, just pay attention. If you need to simplify, then do that. Solve the following equation using the quadratic formula. This one's a little bit nicer, so we should be able to do this. We have a equals 1, b equals negative 5, and c equals 3. So our formula is negative b, so that's 5, plus or minus the square root of b squared, so that's 25, minus 4 times a times c, all over 2a. This one, if you notice the discriminant there in the inside, what we end up with is 25 minus 12. So we get 5 plus or minus the square root of 13 over 2. On this problem, we want to solve, and it says try factoring first, which might seem weird, but then it also says if factoring doesn't work, use a quadratic formula, which also might sound weird if you look and you notice this isn't a quadratic. So you'll notice that this is a bunch of fractions. This is a rational equation, but the first thing we're going to do is we're going to make it no longer a rational equation. We're going to find the LCD, and we're going to multiply everything by the LCD. So let's try it. The first one, we're going to have to multiply by the x plus 7 and by the 4 so that they all have the same denominator. And then once we do that, it'll cancel out some stuff, but it won't cancel out the 4 and the x plus 7. As you go through this, what you'll see is that each piece gets canceled out in the denominator, and the pieces that weren't there remain. And so after finding the LCD, which was each of those factors, and then multiplying the entire equation by all 3 of those factors, what you'll get is you'll get some stuff that looks like this. We can then clean it up a little bit, and we're going to try to do that here. Now we're starting to see why we were supposed to solve it by factoring, if possible, if not, use quadratic formula. And that's because if you look at this, now we have a quadratic. So I'm going to go ahead and solve it like I would have solved a quadratic by getting the whole thing equal to 0. So I'm going to subtract 8x from both sides, and then I'm also going to subtract the 28. And I'll end up with 0 equals x squared minus 1x minus 28. Now, it says solve by factoring if I can, and I don't think I can. I don't see how I would solve this one by factoring. So that means I want to use the quadratic formula, and we're going to do that just by plugging in a equals 1, b equals -1, and c equals -28. We're going to use the quadratic formula, so that's negative b plus or minus the square root of b squared minus 4ac all over 2a. Now there might be some simplification. If we're lucky, this simplifies really nice. If not, then we're going to leave it. But the important thing is we're going to notice, unless we have 0, that we're going to have 2 answers. 78. Solve the following equation using the quadratic formula. The quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. Now, that's something I've memorized. If you don't, that's okay. But how we do that is the first thing we have to do is we get it equal to 0. And then we label our a, b, and c. A is our first coefficient of 1, b is -12, and c is 49. Then we're going to plug it into our formula. And what we get is negative b, so that's positive 12, plus or minus the square root of b squared, so that's 144, minus 4 times a times c all over 2 times a. Okay, now it becomes just a matter of making sure we're typing in the calculator correctly and doing our calculations carefully. Okay, but if we do, what are we going to end up with? Well, we're going to end up with kind of an ugly answer. So let's walk through it. I'm going to do it by hand just for funsies, which means on the bottom I have a 2 still. I have a 12 here, but the meat of my problem is trying to simplify that square root. So 4 times 1 times 49, what does that equal? That equals 146. Okay, so I need to subtract, sorry, let me do that right, 196. Check my math there. And so if we're going to subtract that, we end up getting plus or minus the square root of actually a negative number. Okay, and so if I go negative, and that would give me 52. So I could either keep going and deal with the fact that we have an imaginary number, but also I want you to recognize, after we simplify that, pay attention to whether or not your answer allows you to give imaginary numbers or complex numbers, because since this has a negative in the square root, then there is no real solution. So if that's an option, then you can save yourself some time and just check the inside of that to find the answer, or should find whether there is an answer. This one says, hey, don't do all the work, please. It just says find the discriminant. So what we're going to do is first get it equal to 0. 4z squared plus 4z plus 5 equals 0. And so a equals 4, b equals 4, and c equals 5. So we're going to try this in just the discriminant, which was the part in the square root. So that's b squared, so 16, minus 4 times a, which is also 4, times c, which is 5. And if we were to multiply that all out, what we'd end up is a negative number in here. So what we'd say is we have 2 non-real solutions. They exist, they just don't really exist. They're imaginary. Solved by factoring. This is a quadratic equation. So the first thing I'm going to do is, if I'm going to solve it by factoring, is get it equal to 0. So I'm going to subtract and get things all over on the left, so it's equal to 0. So I have r squared plus 2r minus 35 equals 0. Now we're just going to factor by finding two numbers that multiply to negative 35. And so one of them is negative, and they need to add to a positive 2. So the bigger number will be positive. So I think this one's not too bad because we have r plus 7 and r minus 5. Last thing is we'll remember that our solutions are actually the opposites of our factors. So our two answers are negative 7 and positive 5. Solved by factoring, this is a quadratic. There's an exponent, but the first thing I need to do if I'm going to solve by factoring is get it all equal to 0. So I'm going to subtract 5x from both sides. And I get 3x squared minus 3x equals 0. Now this is kind of funny because this is just a binomial, not a trinomial. So my first tactic, my strategy, is going to be to take out the greatest common factor. So I can actually take a 3x out of both terms, and that would leave me an x minus 1. Now I have two factors equal to 0, so I'm going to set them each equal to 0. 3x equals 0. Well, that would give me x equals 0. And then I have x minus 1 equals 0. And so if I add 1 to both sides, I get x equals 1. So those are my two solutions. Find all real and complex roots. Okay, this one scares people. Why does it scare people? Well, because it's got an x to the fourth. But the nice thing is we have a formula for find x. It's the quadratic formula. But instead, we're just going to treat this problem like it just was x squared. So I'm just going to kind of make a note that x really is x squared. Okay, if we wanted to be like coy, so make sure we didn't forget, I'm going to say that y equals x squared. So I'm going to rewrite this as y squared minus 2y minus 24 equals 0. If we're trying to find all the complex roots, then I'm going to start right here and say, can I solve this? And yeah, this looks like it's factorable at y minus 6 and y plus 4. And so I already have two answers. I've got y equals 6 and y equals negative 4. Although, remember, y represented x squared. So now I'm going to rewrite my equations as x squared equals 6 and x squared equals negative 4. Now, if I use my square root property to get this, I'm going to say x equals plus or minus the square root of 6, or x equals plus or minus the square root of negative 4. Now I can simplify that to be x equals plus or minus 2i. So I have two real roots. They're irrational, but they're real. And two imaginary roots or complex roots. Graph the quadratic equation. This isn't too bad if you know your parent functions. Your parent functions are the basic functions. So the parent function for this one is y equals x squared. And I know that's a parabola. A parabola is a U shape, and it looks like this. Until you start changing it, this is what it looks like. So there we have it. But this says x squared minus 4. So all we have to do is subtract 4. In other words, we're going to move this down 4. And graph it. And guess what? That's my answer. We're going to graph this quadratic equation. Now, this one looks a little bit intimidating because we have a leading coefficient that's not 1. So we need to first talk about the vertex. How do we find the vertex of a quadratic equation? Now, you probably know that a quadratic equation looks like a U, a parabola, either up or down. If it's positive, and this one is, we're going to go up. So it's going to look something like that. But we need to know where and kind of how stretched it is. So there is a way we can do this, and we're going to use the quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac all over 2a. But I'm not going to use the whole thing, okay? Because I'm not worried about anything right now except for the vertex, then I'm only going to be focused on this part before the plus or minus. Because the plus or minus is what gives me each side of a parabola. The negative b 2a tells me the center. Okay, so my equation, remember, is x equals, that's what the quadratic formula says. So my equation for my vertex has an x exactly at negative b over 2a. So what we're going to do is we're going to look for a equals 2, b equals 4, and c, we don't need it right now, right? So if I plug in those numbers, what I would get is negative 4 over 2 times 2, which is 4. And so my vertex is negative 1. Now, that's only one of my two ordered pairs. So in order to find our matching y, what we do is we plug that negative 1 in for x to see what we get for y. So I'm going to try that now. Y equals 2 times negative 1 squared plus 4 times negative 1 plus 3. So if I do a little bit of math, I get y equals 2 minus 4 plus 3. So negative 1, 1. And so now I have my vertex at negative 1, 1. And that tells us where our vertex is, but we might want to also find out a couple other things. We might want to find out the y-intercept, might be a useful thing for graphing. And our y-intercept is pretty easy to find because if you remember, y-intercepts are when the x is 0, what is the y? Well, that's pretty easy to plug in 0, right? If I plug in 0 in this equation, the y is 3. Now, the last thing they might ask us to do, other than just simply graphing it, because we could pretty much graph this now. If you were using the computer to do this, you go ahead and click on the icon that looks like this parabola, and then you put the vertex, and then you put 1 point. And now we have the vertex and 1 point. We have negative 1, 1, which is a vertex. We also have 0, 3 for our y-intercept. So we could graph it right now. But let's say it asks us for one more thing. It might ask for x-intercepts. How do we find those? We use the quadratic formula, okay? And that'll give us our two x-intercepts, if there are any. This one says find the domain and range of the relation, and then say whether the relation is a function. So first, we're going to say domain. The domain is all of the x values. Now, when we're writing out the domain, we list them, and we put curly braces, but also we don't repeat. So if I ever see one that's the same number twice, like this one, I'm not going to repeat it. Okay, so my domain is just those three numbers because two of the numbers were the same. My range is all my y values. And again, we're going to use curly bracket, and I'm going to write my values, but if it repeats, I do not repeat it. So I have my domain and range, but the second part says whether it's a relation or a function. Is this relation a function? And the rule for whether it's a function is functions are not, I should say it's not a function if repeat x's give different y's. So let's take a look at our repeat x's. Now I'm not looking at my repeat y's, I'm looking at my repeat x's. So we said that 5/8 was here twice. When you look at 5/8, the first time 5/8 was paired up with a 3. So if it was a function, every time I see 5/8, it should be paired up with a 3. But this time, it was paired up with a -6. So this is not a function. Determine whether this relation is a function. Now, first off, this is a constant function. This is a function. And if you were to graph it, what you get is y equals 4 is a horizontal line. And when we graph it, we can think it and say, does it pass the vertical line test? And so, yes, this is a function. Determine whether this is a function. Okay, if you would try to solve it for a y equals, okay, that's kind of the way we determine when we have an equation whether it's a function. If it can be y equals, then it's a function. So the first thing we're going to do to try to get y equals, just y equals, is we're going to try to divide by 2. And so I now have y squared equals x over 2. And then we still got the y not by itself. So if I square root both sides, Remember that the square root means that we have a plus or minus. And so this is our giveaway for whether something is or is not a function. If I get a y equals, and there's more than one answer on the other side, so if I have a plus or minus, then I have a problem. Okay, so y equals, if there's a plus or minus, then it is not a function. For each of these, find the following. And now, do not think this is f times x. That fx notation is to just say, hey, we've got a function of x, and what I want you to do is plug everywhere you see an x, I want you to plug a 0. And so for that, what we'd say is f of 0, and we plug it in, and what we get is 0. So f of 0 is 0. If we plugged in -5, well, what will we get? Well, we get 115. And if we plugged in f of 5, we get 135. Those would be our answers. For the function, find a f of a minus 3. So don't just plug in a, don't just plug in -3. Plug in where this is an x, plug in a minus 3. And so f of a minus 3 equals 4 times a minus 3 minus 7. We're going to distribute a little bit and get 4a minus 12 minus 7 equals 4a minus 19. Find this very bizarre thing for this function. Okay, so according to this, we need 3 things. First, we need an f of x plus h. So I'm going to just start there. We have an f of x, and I need an f of x plus h. And so that means we're going to replace the x with an x plus h in our function. And I have to do that everywhere I see an x, I'm going to put an x plus h. Then we're going to go ahead and distribute. Don't just distribute that exponent, but rather FOIL out in this first one. And if we do that, the first one's going to become x squared, and then it's going to be plus 2xh plus h squared, and then the last part is minus 5x minus 5h. And from here, we should be able to clean this up a little bit and say f of x plus h. I'm just combining like terms here. F of x plus h is x squared. Well, I'm not even going to clean it up. It's ugly. Let's just leave it what it is. It's ugly. I could try to reorder it, but there is no like terms to combine. Okay, so that's the point I'm trying to make here. The next thing it says is after we find the f of x plus h, it says go ahead and subtract f of x from that. Okay, that seems weird, but here's what I'm going to do. I'm going to go ahead and do that, and I'm going to line it up. Okay, so f of x is x squared, so I'm going to take the x squared and put it there, and the minus 5x, so I'm going to put minus 5x. And since we're subtracting, I'm going to switch the signs. All right, so if we go ahead and subtract those, like it says, what we get is 2xh plus h squared minus 5h. Which brings us to the last step. The last step, and it says down at the bottom, divide the whole thing by h. So we're going to do that. I'm going to divide the whole thing by h. Another way to say that is to divide each h out. And so what I'd end up with, if I did that, there's an h that cancels out of each term, and so I have 2x minus 5 plus h. And that's my final answer. It doesn't feel like it's finished, but that just know that what we're building on here, what they're asking here, is something that's useful in things like calculus. And so we've just kind of mentioned it, but we didn't really give you a reason for why we were finding this very specific thing. Let's talk about domain. Finding the domain of a rational function comes down to figuring out what would break it. And what would break this is if the denominator were 0. So I just want to find out what numbers would make this 0. Now, one effective way to do that would be to factor it, because when we set a quadratic equal to 0, we factor it. And so this one is x plus 1 and x plus 8. So when does it equal 0? Well, it equals 0 when x equals negative 1 and x equals negative 8. So my domain is all real numbers not equal to negative 1 or negative 8. If I needed to write that in interval notation, I would say, hey, you can start all the way at negative infinity and go all the way to negative 8, but then I need you to skip negative 8 and then pick up on the other side of negative 8. So at negative 8, just a little bit past it, and go all the way until you get to negative 1, and then skip to the other side of negative 1, and then go all the way to infinity. Find the domain of this radical function. Now, radicals, if they're even powered or even index, then they can't be a negative. So in other words, what we're saying is what's in there, the 3p minus 2, has to be greater than or equal to 0. So we're going to try to solve that and figure out what the answer is. So the domain should be the answer to that inequality. So we're going to add 2 to both sides. And then divide by 3. And we get p is greater than or equal to 2/3. And so that is my domain. My domain is that problem right there. If I need it in interval notation, I'd say from 2, 3 inclusive all the way to positive infinity.